The value of f of x is nearly equal to L when x is nearly equal to C. F of x minus L is less than epsilon when x minus x naught is less than delta. Then the value L is called the limit of a function when x tends to x naught. Using a cube minus b cube, we know the formula for a cube minus b cube. A cube minus b cube is equal to a minus b into a square plus ab plus b square. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important and easiest chapter, that is limit and continuity of a function. Now, before going to exact the definition and the problem, let us see the weightage for this chapter. You are going to get one mark question and one 2 mark question and one 6 marks question, that is from part E. So, this is very important. Now, just I am going to discuss regarding the first part, that is limits. In the limits, first part is limit and second part is the differentiability. In limits, we are going to get one 1 mark question and one 2 marks question and one 6 marks question, that is in part E you are going to get one 6 marks question. Usually you are going to get the theorem. There are two theorems, theorem 1 and theorem 2. So in those theorems you will get one theorem for part E. Now let us discuss in detail the definition of the limit of a function. What do you know regarding the limit of a function? So usually the limit of a function is denoted as, you might have been studied in your previous classes, limit x tends to a of f of x is equal to L. So sometimes we can also represent limit as LT, limit x tends to a of f of x is equal to L. Now let me explain in detail what is the definition for the limit of a function. Now, so let us consider a real valued function f. Suppose if f is a real valued function and the real number c, the limit is normally defined as limit f of x as x tends to c is equal to L. Here f is a function, a real valued function, and c is a real valued number. Then the limit of this function is defined as limit x tends to c of f of x is equal to L, or limit x tends to c of f of x is equal to L. How to read this? This can be read it as the limit f of x as x approaches to c is equal to L. That means the value of f of x is nearly equal to L when x is nearly equal to c. And the fact that the function f of x approaches to the limit L as x approaches to c is described by this arrow. See here, as x approaches to a value c and this f of x, y is equal to f of x approaches to a particular value, say for example 4, then this arrow mark indicates the value of the limit. So that is the limit as x approaches, that is the fact that the function f of x approaches to the limit L as x approaches to c is described by this right arrow. This is how we are going to represent in a diagram. Now let us define the definition for the limit of a function. Now how to define the limit of a function? Now let us come to the definition. So a function y is equal to f of x is said to tends to a limit L. A function y is equal to f of x is said to be tends to a limit L as x tends to x naught. Suppose if given epsilon greater than 0, however small it may be, there exists a delta greater than 0 such that mod of f of x minus L is less than epsilon when x minus x naught is less than delta. So, and it is denoted as limit x tends to a of f of x is equal to L. So, or this can also be denoted as limit x tends to x naught of f of x is equal to L. This is the definition of the limit of a function. So, here a function y is equal to f of x is said to be tends to a limit L as x tends to x naught. If given epsilon greater than 0, however small it may be, there exists a delta greater than 0 such that f of x minus L is less than epsilon when x minus x naught is less than delta, and it is denoted as limit x tends to x naught f of x is equal to x, f of x is equal to L. So that is, it is denoted as limit x tends to x naught of f of x is equal to L. That means f of x minus L is less than epsilon when x minus x naught is less than delta, then the value L is called the limit of a function when x tends to x naught. Or this can also be denoted as limit x tends to a of f of x is equal to L. What is the meaning? The meaning of this statement is the value of f of x is nearly equal to L when x is nearly equal to a. That's all. In general, the value of f of x is equal to L when x is nearly equal to a. If x is replaced by a, then you are going to get L. That itself is called the value of the limit. That is the meaning of this statement. Now, let us come to the properties of limits. So, there are few properties of limits. The following are the list of properties. Now, let us assume there are two limits. Limit x tends to f of x and limit x tends to a of g of x are two functions. So, let us consider two limits, limit of f of x and g of x. Limit x tends to a of f of x, limit x tends to a of g of x. Then, there exists a constant c. C is a constant. Then, first limit x tends to a of constant into f of x is equal to c into the constant is kept out and apply the limit for the function. First property, limit x tends to a of c into f of x, where c is a constant, then constant c is out, c into, apply the limit for the function, limit x tends to a of f of x. Or we can also write like this, limit x tends to a of a constant into function, where k is the constant, then you can take constant out and apply the limit for the function, limit x tends to a of f of x. This is the first property. So, limit x tends k into f of x always equal to k is kept out and apply the limit for the function, limit x tends to f of x. Now, come to the second one. So, that is limit x tends to of f of x plus or minus g of x. If it is the sum or difference, two function, sum plus difference minus limit x tends to f of x plus or minus g of x is equal to limit x tends to of f of x, first function. If it is negative means minus limit x tends to of g of x. So, limit x tends to of f of x plus or minus g of x is always equal to limit x tends to of f of x plus or minus limit x tends to g of x. That is sum or difference of two functions. So, that means select the limits individually and put them back with the corresponding signs. Now, next let us consider the third property, limit x tends to of f of x into g of x, that is the product. So, limit x tends to of f of x into g of x is always equal to limit of first function into limit of second function, that is limit x tends to of f of x into limit x tends to of g of x. That means consider the limit of product of similar to the limit of sum or the difference. The product is into and sum or difference is plus or a minus. Just select the limit of the piece and put back, and this is not limited to only two functions. Suppose if there are number of terms, limit x tends to of f of x plus or minus g of x plus or minus h of x, etc. Then we can apply term by term limits. Okay. Now, let us come to the next property, property number 4, the quotient of a function. So, limit x tends to of f of x divided by g of x is equal to limit x tends to of f of x divided by limit x tends to of g of x. Just apply the limit for numerator divided by the limit for the denominator, provided the denominator is not equal to 0. If limit x tends to of g of x is equal to 0, then the denominator becomes 0, means 0 by any number it yields to, which is an infinite number. So, we can see we need to bother only the limit of the denominator is 0. Denominator should not be equal to 0 when applying the property for this limit. If it is 0, then the division by 0 is an error. We won't get the answer, we will get an infinite number. Right. So, this is how we are going to apply the properties for the limit of a function. The next one is limit x tends to a of c is equal to c. That means the limit of a constant is only a constant. Limit of a constant is always a constant. So, here this can be easily understood by plotting the graph of f of x is equal to c. Now, limit x into n is equal to, just apply the limit, put x is equal to a, then this becomes a into n. So, these are few properties of a limit of a function. Now, in general, suppose if, let us consider limit x tends to a of f of x is equal to L and limit x tends to a of another function g of x is equal to m, then one by one, what are the properties we have? Limit x tends to a of f of x plus or minus g of x can be written as limit x tends to a of f of x plus or minus limit x tends to a of g of x. This can be written as L plus or minus m. Okay. Limit of first function is L, second function is L plus or minus m. Similarly, the important one is limit x tends to a of f of x into g of x can also be written as limit x tends to a of f of x into limit x tends to a of g of x. This can be written as L into m. L into m. L plus or minus m, L into m. And the third one, that is limit x tends to a of f of x divided by g of x is nothing but limit x tends to a of f of x divided by limit x tends to a of g of x. This can be written as L by L. So, these are the few basic properties of a limit of a function. Now, based on this, let us take few problems, simple problems on this. Now, hope you got an idea what is the definition of a limit and how to evaluate the limit of a function. Now, let us come to the problem. I will take few simple problems. Now, there are two important theorems in this limit. So, before going to the exact theorem, let us explain few basic concepts of these limits. Now, compute limit x tends to minus 4 of 5x square plus 8x minus 3. Just put x is equal to, minus 4, that's all. Here, the value of L, so the value of A is minus 4 and the value of L is to be determined, and f of x is equal to 5x square minus 8x minus 3. Now, put x is equal to minus 4, 5 into minus 4 whole square plus 8 into minus 4 minus 3. So, this is 5 into minus plus 4 4s are 16 plus 8 into minus 4 minus 3 as it is. Now, multiply this. 5 into 16 plus 8 into minus 4 minus 3. I will write here. So, this is equal to 16 into 5 is 80, minus into plus it is minus, 8 into 4, 32, minus 3. So, this is 80 minus 35. 80 minus 35 is nothing but 45. That's it. Okay. So, listen. Just put x is equal to minus 4 here. 5 into minus 4 whole square plus 8 into minus 4 minus 3. Minus 4 whole square is 16. 4 4s are 16. 8 into minus 4 minus 3. Multiply this. 16 into 5 is 80. Plus into minus minus. 8 4s are 32 minus 3. 80 minus 32 minus 3 is minus 35. 80 minus 35 is 45. So, here this is nothing but the value, this is the value of L. So, the value of x is A. So, x tends to minus 4 means x tends to A. Here A is equal to minus 4 and the function f of x is equal to 5x square plus 8x minus 3 and the value of L is equal to 45. So, the value of f of x is nearly equal to 45 and x is nearly equal to minus 4. That is the meaning. That is denoted as limit x tends to a of f of x is equal to L. In the definition, we have represented the limit x tends to a of f of x is equal to L. That means here L is equal to 45, f of x is equal to 5x square plus 8x minus 3 and x tends to a, the value of a is equal to minus 4. This is how we are going to evaluate a limit. Now, let us come to the next problem. Compute or evaluate limit x tends to 6 of x minus 3 into x minus 2 divided by x minus 4. So, just put x is equal to 6, that's all. Put x is equal to 6. If you put x is equal to 6, then what you will get? 6 minus 3 into 6 minus 2 divided by 6 minus 4. Simplify this. So, this is equal to 6 minus 3 is 3, 6 minus 2 is 4 divided by 6 minus 4 is equal to 2. 2 to the gets cancelled. 3 into 2, that's equal to 6. The value of limit is equal to 6. That's all. See, limit extends to 6 of x minus 3 into x minus 2 divided by x minus 4. Put x is equal to 6. 6 minus 3 is 3. Again, 6 minus 2 is 4. Divided by 6 minus 4 is equal to 2. 2 2 gets cancelled. 3 into 2 is 6. So, the simplified answer, the value of limit is 6 when x is nearly equal to 6. Okay. Now, let us come to the next problem. Limit extends to 3 of x square minus 9 divided by x minus 3. Now, by straight away putting the value of x is equal to 3, put x is equal to 3, then this reduces to 3 square minus 9 divided by 3 minus 3. 3 square is 9 minus 9 divided by 3 minus 3. This is 0 by 0 form. So, 0 by 0, which is an indeterminate form. So, 0 by 0, infinity by infinity, these are all indeterminate form. So, these indeterminate forms can be converted. So, to evaluate this, there is one important formula, that is limit extends to a of x raised to n minus a raised to n divided by x minus a is equal to na to the power of n minus 1. That we will go to the next concept. Before that, this can be evaluated using the algebraic formulas. Limit extends to 3 of this x square minus 9 can be written as 3 square divided by x minus 3. Without using the formula, we can simplify. Now, let us simplify this. Limit extends to 3 of, this is of the form a square minus b square. A square minus b square can be written as a plus b into a minus b, x plus 3 into x minus 3 divided by x minus 3. X minus 3 gets cancelled. Limit extends to 3 of, what is left in the numerator is x plus 3. Put x is equal to 3, then you will get 3 plus 3 is equal to 6. 6 is the value of the limit. So, without using, we can simplify this, right? So, limit extends to 3 of x square minus 9 divided by x minus 3, which is an indeterminate form. By putting x is equal to 3, 0 by 0, which is an indeterminate form, this 9 can be written as 3 square. It is of the form a square minus b square. X plus 3 into x minus 3 divided by x minus 3. X minus 3 gets cancelled. X plus 3, put x is equal to 3. 3 plus 3 is equal to 6. This is how we can evaluate. This can also be simplified using the formula. Okay, that we will discuss in the next coming sessions. Now, let us take one more problem. Here, what is given? Limit x square plus 9 divided by x plus 3. Now, whenever x tends to minus 3. So, by putting x is equal to minus 3, if you put x is equal to minus 3, what you will get? Minus 3 square plus 9 divided by minus 3 plus 3. Minus 3 square is 9 plus 9 divided by 0. So, 9 plus 9 is 18 divided by 0, that's equal to infinite. So, the value of limit is infinity. Okay. If you put x is equal to minus 3, what you will get? Minus 3 square is 9 plus 9, 18 divided by minus 3 plus 3 gets cancelled. So, 18 by 0 is equal to infinite. So, you are going to get it as infinity. Now, let us come to the next problem. What is the next problem? Compute limit extends to 4 of 4x plus 3 divided by x minus 2. This is also a simple problem. Straight away put the value of x is equal to 4. Just put x is equal to 4. Put x is equal to 4. So, this can be written as 4 into 4 plus 3 divided by 4 minus 2. This is the value of a. Put x is equal to 4. 4 into 4 plus 3 divided by 4 minus 2. What is 4 into 4? 16 plus 3 divided by 4 minus 2 is 2. So, 16 plus 3 is nothing but 19 divided by 2. So, the value of limit is 19 by 2. Very simple. Just replace x by 4. You will get the answer. That's it. Okay. Now, let us come to the next problem. These are all simple examples to evaluate the limit of a function. Now, this is what is the problem given. Limit extends to 1 of ax square plus bx plus c divided by cx square plus bx plus a. Now, let us put x is equal to 1 here. By putting x is equal to 1, what is the answer we are going to get? Here, put x is equal to 1. That's equal to a into 1 square plus b into 1 plus c divided by c into 1 square plus b into 1 plus a. So, 1 square is 1, 1 into a is a, b into 1 is b plus c divided by c into 1 square is 1 into c is c plus b into 1 is b plus a. So this can also be written as a plus b plus c in the numerator. Denominator, put it in order, a plus b plus c. So see, observe carefully, these two are same, gets cancelled, this is equal to 1. So the value of limit is 1, a plus b plus c by a plus b plus c gets cancelled, that's equal to 1. That's it, very simple problem. Okay. Now let us take next problem. Compute limit extends to 3 of x square minus 4x divided by x minus 2. This is also very simple and easiest problem. Put x is equal to 3, that's all. If you put x is equal to 3, then what happens? This is 3 square minus 4 into 3 divided by 3 minus 2. 3 square is 9, 3 fours are 12, divided by 3 minus 2 is 1. 9 minus 3, 9 minus 12 is equal to minus 3 by 1 is equal to minus. So the value of limit is equal to minus 3. That's it. See, limit extends to 3 of x square minus 4x divided by x minus 2. Put x is equal to 3. 3 square minus 4 into 3 divided by 3 minus 2. 3 square is 9. 4 3s are 12. 9 minus 12 is minus 3 divided by 3 minus 2 is 1. Minus 3 by 1 is minus 3. That's it. So the value of limit here is minus 3. Hope you are following. These are all very simple problems. These are the basic problems to evaluate the limit. Now let us come to the next problem. Limit extends to 1 of x cube minus 1 divided by x minus 1. Now just put x is equal to 1. By putting x is equal to 1, what is this? 1 cube minus 1 divided by 1 minus 1. 1 cube is 1 minus 1 by 1 minus 1. 0 by 0 form is obtained. 0 by 0 form is obtained, which is an indeterminate form. So which is an indeterminate form. This can be simplified. So using a cube minus b cube, we know the formula for a cube minus b cube. A cube minus b cube is equal to a minus b into a square plus ab plus b square. Now use this formula. So this can be written as limit extends to 1 of a cube minus b cube. A is equal to x, b is equal to 1. A minus b, x minus 1 into a square, x square plus ab. 1 into x is x plus b square. 1 square is 1 divided by the denominator x minus 1. X minus 1 gets cancelled. What is left over is limit extends to 1 of x square plus x plus 1. Now put x is equal to 1. If put x is equal to 1, 1 square plus 1 plus 1. 1 plus 1 plus 1 is equal to 3. So the value of limit is equal to 3. That's it. Very simple. See, by putting x is equal to 1, 0 by 0, which is an indeterminate form, is obtained. Now this can be simplified as using a cube minus b cube. A cube minus b cube is equal to a minus b into a square plus ab plus b square. X minus 1 into x square plus x plus 1 divided by x minus 1. So x minus 1 gets cancelled, and what is left? X square plus x plus 1. Just put x is equal to 1. That's it. So if you put x is equal to 1, 1 square plus 1 plus 1 is 1 plus 1 plus 1 is 3. That's all. This is the simplest method to solve this problem and very easiest one. Hope you followed. Okay, now let us come to the next problem. So compute x square minus 4x plus 3 divided by x square minus 2x minus 3. Now just put x is equal to 3. By putting x is equal to 3, what we will get? 3 square. 3 square is 9 minus 4 into 3 plus 3 divided by 3 square is 9 minus 2 into 3 minus 3. So this is 9 minus 3 fours are 12 plus 3 divided by 9 minus 2 3s are 6 minus 3. So this is equal to, yes, 9 plus 3. 9 plus 3 is equal to 12 minus 12 divided by 9 minus 9. That is equal to 0 by 0, which is an indeterminate form. So 0 by 0 form, which is an indeterminate form, is obtained. Now let us factorize this numerator and denominator separately and apply the limit. That's it. Now this x square minus 4x plus 3 can be written as, let us factorize this. You can factorize using cross multiplication like this. So here it is minus, we can put minus into minus plus, minus 3x minus x is minus 4x. The factors are x minus 3 into x minus 1. Similarly, here it is x square minus 2x minus 3. This can also be factorized using 3 into 1, x into x, and since minus 3 can also be written as, this is minus 3 and plus 1. See here, what we will get? Minus 3 into plus 1 is minus 3. Minus 3x plus x is minus 2x. The factors are x minus 3 into x plus 1. You can use any method to factorize using just cross multiplication or completing the square. Any method you can use to factorize this. So this is equal to limit x tends to 3 of, what is the numerator? The factors in the numerators are x minus 3 into x minus 1 divided by, in the denominator the factors are x minus 3 into x plus 1. Now cancel the terms which gets cancelled. X minus 3 gets cancelled, and what is left over is limit x tends to 3 of x minus 1 divided by x plus 1. Now put x is equal to 3. If you put x is equal to 3, cancel the terms which gets cancelled, and what is left over is x minus 1 by x plus 1. Put x is equal to 3. The value of limit you will get 3 minus 1 divided by 3 plus 1. 3 minus 1 is 2 divided by 4. This is equal to 1 by 2. The answer for this problem is 1 by 2. Very simple. So you can use any method to factorize so that you will get the factors. So in the numerator and denominator, the factors get cancelled, the terms which gets cancelled, and apply the limit, you will get the answer. That's it. Okay. This is how we are going to solve this problem. Let me take a similar type of problem. Okay. Now evaluate 2x cube minus 5x square plus 2 divided by x square minus 3x plus 2. Now just put x is equal to 2 here. If you put x is equal to 2, put x is equal to 2, then this is 2 into 2 cube minus 5 into 2 plus 2 divided by 2 square minus 3 into 2 plus 2. So this is 2 cube is 8, 8 2s are 16 minus 5 2s are 10 plus 2 divided by, here in the numerator 2 square is 4 minus 3 2s are 6 plus 2. So this is equal to, so let me write here 16 minus 10, 16 minus 10, 16 minus 10 is 6 plus 2 divided by, in the denominator 2 plus 4 is 6 minus 6 is 0. This is 8 by 0, which is equal to infinity. So we won't get 0 by 0. If it is 0 by 0, then we have to go for the factorization. Right. So see here, what is given? Limit x tends to 2 of 2x cube minus 5x square plus 2 divided by x square minus 3x plus 2. Put x is equal to 2, then this is 2 into 2 cube minus 5 into 2 plus 2 divided by 2 square minus 3 into 2 plus 2. So 2 cube is 8, 2 2s are 4, 4 2s are 8, 2s are 16, 5 2s are 10 plus 2, 16 minus 10 is 6 plus 2 divided by 2 square is 4, 3 2s are 6 plus 2, 4 plus 2 is 6 minus 6 is equal to 0, 8 divided by 0 is equal to infinity. So the answer for this is an infinite number. Suppose if it is 2x square, then we will go for factorization method and simplify, cancel the factors which gets cancelled, we will get the answer. That's it. Now let us come to the next problem. Compute a limit x tends to 2 of 3x square minus x minus 10 divided by x square minus 4. Now just by putting x is equal to 2, by putting x is equal to 2, what we will get in the numerator? 3 into 2 square is 4 minus 2 minus 10 divided by 2 square minus 4. So 3 4s are 12 minus 12 divided by 2 square is 4 minus 4. That's equal to 0 by 0, which is an indeterminate form is obtained. 0 by 0, which is an indeterminate form. Now let us factorize the numerator 3x square minus x minus 10. This can be factorized as, let us write this as 5 into 2. 5 2s are 10. This is 3x into x, 3x square. Now if you simplify this, you will get the middle term as minus x. So let us represent this as minus and plus c. Plus 3 into 2 is minus 6x, plus 5x into 1 is 5x. If you simplify, you will get minus x as the middle term. So the factors are 3x plus 5 into x minus 2. Now whereas the denominator x square minus 4 can also be written as x plus 2 into x minus 2, because 4 can be written as 2 square. So x square minus 4 is nothing but x plus 2 into x minus 2. So this limit converts to limit x tends to 2 of, What is the numerator? In the numerator, the factors are 3x plus 5 into x minus 2 divided by, in the denominator, the factors are x plus 2 into x minus 2. Now these two gets cancelled. What is left in the numerator is limit extends to 2 of 3x plus 5 divided by x plus 2. Now put x is equal to 2. This is 3 into 2 plus 5 divided by 2 plus 2 in the denominator. So 3 2s are 6 plus 5 is 11 divided by 4. The simplified answer is 11 divided by 4. That's it. So we have to apply the limit for both numerator as well as the denominator. This is the simplified answer. Very important problem. Now let us come to the last problem in this concept. That is, compute limit extends to 3 of x to the power of 4 minus 81 divided by 2x square minus 5x minus 3. Now check whether it is of indeterminate form or not. Now by putting x is equal to 3, what we will get here? 3 to the power of 4 minus 81 divided by 2 into 3 square minus 5 into 3 minus 3. So this is 3 3s are 9, 9 3s are 27, 3s are 81 minus 81 divided by, in the denominator, 3 square is 9, 9 2s are 18 minus 5 3s are 15 minus 3. So 81 minus 81 divided by 18 minus 18, 0 by 0, which is an indeterminate form is obtained. Okay. Now factorize this. That's all. Now here this can be written as x to the power of 4 minus 81 can be written as x square whole square minus 81 can also be written as 9 square. 9 square. Now if you observe carefully, this is of the form a square minus b square. What is the formula for a square minus b square? As you know, a plus b into a minus b. This can be written as x square plus 9 is one factor. Another factor is x square minus 9 is another factor. See, if you multiply x square into x square, x to the power of 4 plus into minus minus 9 9s are 81. Whereas in the denominator, this denominator 2x square minus 5x minus 3. This can be factorized using factorization method, or you can also use like this. 2x square minus 5x can also be written as minus 6x plus x minus 3. So minus 6x plus x is minus 5x. So you can take 2x common factor, x minus 3, plus 1 common factor, x minus 3. The factors are x minus 3 into 2x plus 1 are the factor. Otherwise, you can go for cross multiplication, which I did in the previous problem. Now, therefore, this given limit can be written as limit extends to 3 of, what is there in the numerator? In the numerator, we have x square plus 9 into x square minus 9 divided by, in the denominator, the factors are x minus 3 into 2x plus 1. Again, if you apply the limit, you will get 0 by 0. Now, let us convert this again. Limit extends to 3 of, this first part is same, x square plus 9 as it is. This can be written as x square minus 9 can be written as 3 square. So, therefore, this can also be written as x plus 3 into x minus 3 divided by, the denominator is x minus 3 into 2x plus 1. Now, this x minus 3 gets cancelled. Now, put x is equal to 3 now. 3 square plus 9 into 3 plus 3 divided by, in the denominator, 2 into 3 plus 1. So, the simplified answer is 3 square is 9, 9 plus 9 is 18 into 3 plus 3 is 6 divided by 2 into 3, 6 plus 1 is 7. So, the simplified answer is 18 into 6 divided by 7. So, this is equal to 108 divided by 7. So, 108 divided by 7 is the simplified answer for this. 108 by 7. That's it. Hope you followed. Okay. This is how we are going to solve the problems based on the properties of limits. So, that's all regarding today's session. Let us meet with the different concept. In the next session, I am going to take very important theorems and the problems based on those theorems. So, that's all for today's session. Let us meet with different concept in the next session. Thank you. Thank you very much.